Hello students, hope you're all doing well. So today we'll be starting with the chapter which is there, that is the 7th chapter, study of compounds, and among that we'll be studying about sulfuric acid. Now in sulfuric acid, what all things are there if you just have a look? So the first thing which is there, children, is just the introduction. This is one of the most common acid that you all know, and about this you all must have heard also. So we'll be seeing just what all the things they are there that are related to the sulfuric acid. Now if you see, children, here in the introduction part, what has been given, that it was discovered. Okay, so initially when it was discovered, it wasn't called sulfuric acid. Instead it was called what? It was called oil of vitriol. So this is also a question, children, that you can be asked, that what was sulfuric acid called initially, or what was the name of sulfuric acid before the name sulfuric acid was discovered. Okay, so why was it called oil of vitriol, children? Because it was made by distillating the green vitriol, and then you should know what is green vitriol. Okay, so we will know what is green vitriol, children. Green vitriol is nothing but that is hydrated ferrous sulfate. Okay, so that is also called what? FeSO4. So this is my ferrous sulfate, and then when you are adding 7 parts of water, this becomes green vitriol. So this also name you have to remember. This is called green vitriol. Now then when we distill it, and then whatever we are getting, so what is distillation, children? You know that you are heating it in a open pan, and then you are just collecting the condensed part which is there, that is called distillation. So upon the heating of FeSO4, whatever was obtained in the distillation part, that was called what? Oil of vitriol. Okay, and then this is the thing. So initially we found what? The things that were found upon the reaction were Fe2O3. Okay, when this was distilled, Fe2O3, and then we had SO2. Further we had what? We had SO3 and 14H2O. So what happened, children? This was the thing that I was getting upon heating this, and then what happened among this? See, SO3 I took, and then from here I took 1H2O. Okay, so this became how much? This is turning in. Okay, so this becomes H2SO4, and then further here I am left with 13H2O. So this was the reaction. Okay, so these two combined to give me 1 molecule of H2SO4 and 13 molecules of water. Okay, so this was the initial way it was being prepared, and since it was obtained from the green vitriol upon distillation, therefore it was called oil of vitriol. Alright, then we'll be moving to the second thing, that is occurrence, children, that how does sulfuric acid occur in the environment. So what is happening here, children? If you see, in the free, sulfuric acid is found in free state as well as combined state. So I'll just write down here. Okay, so when we talk about sulfuric acid, it is being found in 2 states, children. So the first state is called free state, as you can see it's there, and then the second is called combined state. Okay, of course these are the 2 possibilities which are there, children. Either a compound can be found in the free state or in the combined state. So in the free state, it occurs in minute traces of hot springs. Okay, so this is you must have studied about hot springs in the biology. So it is found in the minute traces, means what? Whatever hot springs are there, in that the traces of sulfuric acids are being formed. So in the free state they will be found in hot springs. And then when we talk about combined form, it is occurred as salts of minerals. Okay, salts of minerals. So, and then when it is in the combined form, we will be applying certain ways so that we can just extract our sulfuric acid from them. Furthermore, in the free state, it is also formed near sulfide beds. Okay, so you know what is iron pyrite? Iron pyrite is an ore of iron which contains sulfur. So it is also found in near the sulfide beds. That is what they are talking about. So whenever the process of hydrolysis of iron pyrite takes place, children, there also we'll be getting sulfuric acid in the free state. So here you will be also writing what? Hydrolysis of iron pyrite. Okay, so these are the occurrence of this. Now if you move to the third part, children, what is the general method of preparation? Of course, if we want to prepare this in a large scale, okay, so we'll be applying a certain industrial method. That method is called contact process, that we'll be discussing. But then in the laboratory condition, or if you want to prepare that at a smaller level, okay, or you want to carry out the preparation in your school laboratory, then how do we prepare this? By the action of heat on nitric acid and sulfur. Means what? What is nitric acid, children? This is HNO3. When these reacts with the sulfur, the non-metal sulfur which is there, children, and then you should know that this nitric acid has to be concentrated. Then these upon reaction will be giving me 6 times of NO2 plus 2 times of H2O plus H2SO4. So if you are having sulfur and nitric acid with you in your laboratory, and then you have to remember that it should be a concentrated one, then you can easily get sulfuric acid. If you see the second way is by passage of chlorine through an aqueous solution of sulfur dioxide. So what is aqueous solution, children? Means suppose I am having this is sulfur dioxide, and when we talk about aqueous, means what? I am adding water to it, and then what is being passing means what? We are reacting. So since Cl2 is a gas, you just cannot mix it because they are not liquids. So when we say we are passing gas, means what? In this solution I'll be adding the Cl2 gas, and then here what I'll be getting, these two H2 and Cl2 will be giving me 2HCl, and then of course we have 2 times. So again I am left with 2 more H2, so it will be giving me H2S, here 2O and here 2O, so this is H2SO4. Okay, so the second way is there. If I am having aqueous solution of sulfur dioxide, then if I am passing the chlorine gas into it, then also I can get. Next way is called the hydrolysis of by dissolution of sulfur trioxide in water. Okay, so the next thing, what is dissolution, children? Here it means that I am trying to dissolve. So suppose sulfur trioxide, if it is there in a concentrated state or if it is there in a solidified state, then I'll be done. So dissolution is nothing but making the solution aqueous. So whenever I am trying to make that aqueous, that is also giving me H2SO4. Okay, and then when we talk about the fourth one, by hydrolysis of sulfuryl chloride. So what is sulfuryl chloride, children? It is a compound which contains sulfur and then it contains chlorines as well. The formula which is there is SO2Cl2. So when this SO2Cl2, it reacts with 2 molecules of water. This is also giving me H2SO4 plus HCl. Okay, so these are the 4 ways, and if you see, usually in laboratory, children, we will be using this first method which is there, and it, of course, it also depends upon the things which are there in your laboratory. Based on that, you can easily prepare the sulfuric acid. And then there also we have concentrated and dilute sulfuric acid, and we all know, children, that sulfuric acid is a very strong acid, so you have to be very careful about that. Now here, children, if you see, this is the entire process of manufacture of sulfuric acid, and the process which is there is called, it's very famous, and this is called contact process. Now where do we apply this contact process, children? If we want to have a large scale industrial production of sulfuric acid. Okay, so here you can see there are chambers over here, and then in the next page you will be seeing all the explanation of these chambers. Now I'll be explaining you what are the parts of this unit. Now in the production of H2O, if you see the A1, I'll show you with the different ink. So this is my A. So this A is what, children? It is blower. So what is blower actually? It will be for, you will be passing the purified air or the oxygen. Anyways, purified air will be having oxygen and then you will be passing that. Okay, so that is because in the process you will be needing pure air, children. You have to remember this. Not just any air, you should have a pure air. And then the second one is my sulfur. This is the thing, the second chamber. If you see, children, this is the sulfur burner. Okay, so here what I'll be taking sulfur, or else I'll be taking a pyrite. So pyrite means, in the sense, I can have iron pyrite or whatever. Okay, so means there should be a compound which contains sulfur in it. Then this is the thing. And then why do we have for production of sulfur dioxide? By burning sulfur or iron pyrites. Why am I taking sulfur? Because sulfur is going to give me sulfur dioxide, and similarly iron pyrite also, it will be on burning giving me SO2. So this is the reason why I am taking it in that burner, because at the end I want sulfur dioxide. Okay, now we will be moving to the second, that is called the purification unit. In the first unit was only these two things, children. In the first unit what we did, only our purpose was to produce sulfur dioxide. Now we will be purifying. Now purifying of gaseous mixture of SO2 and O2. So from where did we get SO2, children? I am getting SO2 from this chamber. And then similarly, from where did I get air? Air I am getting from the A chamber. Then what is happening, children? First is the dusting tower. As we move here, if you see, this is the C. So what happens in dusting tower? It is used for removal of dust particles by downward blow system. Blow of steam. If you see what is happening whenever you are mixing. So from A, air is coming, from B, sulfur dioxide is coming, and then it is falling to this dusting tower, and then steam is being passed from the top of the bottom. And then what happens when the steam is being passed, children? It just removes the air particles which is there. Although we have taken purified air, but still if there are any impure particles, then that will be cleaned by the steam. Then once it is getting cleaned, it will be moving to the D one. If you see, children, everything is there in line. So what happens in D? First of all, if you see, it is in a shape of pipe. So this is called cooling pipe. Now what happens, children? Since you are passing steam over this, then the entire mixture which is there, it gets very heated up. Now as the name suggests, this pipe is going to cool down the entire gaseous mixture. Okay, and then when we say, if you see here, passes through the isolated pipes, means what, children? We haven't given anything or external things over there. It's just a pipe which will be just cooling down the temperature of the mixture. Okay, now in the E, if you see, this is called scrubbing tower. If you can see, this is in the shape of tower. Now what happens this, once the mixture is getting cooled, then again we are passing it to the scrubbing tower. As the name suggests, children, scrubbing means what? You are just taking out the impurities. So once you are removing the impurities in this steam section, again you are passing the water into this, and this is also for remover of impurities, and if at all there are dust particles which are left, that will be removed. Now in the F, what is happening, children? This is a drying tower. If you see this is a drying tower, means what, children? Here see the moist gases which are there. Okay, because once we are if we are passing water over this, it is understood that it will be experiencing some sort of moisture. So for what happens, so if I want to dry out that moisture, so as the name suggests, that is called a drying tower, wherein I'll be drying the moist gases. And then how are you going to moist that? By using concentrated sulfuric acid, and the reactions which are there, children, that will be given in the further section. So the thing is that if you just want to absorb the moisture, you will be using concentrated sulfuric acid. Okay, now in the next section, what is there? It is called arsenic purifier, children. This, if you see, the section G. Okay, this is called arsenic purifier. Now here what is happening, children, the arsenic which is there, it's an element. Now the arsenic oxide, it needs to be removed, because at the end I want only sulfuric acid. So whatever the arsenic oxide is there, that is being removed by passing the ferric hydroxide. Okay, so what are we passing for removing the arsenic oxide, children? I will be passing ferric oxide. Okay, and the related reactions which are there, we will be studying further, children. Okay, and then in the H we having testing box. So this is the testing box which is there, children. And what is this testing box, children? That we have carried out so many processes of purification, of removing moisture, of removing arsenic gas which is there, arsenic oxide. Now after this process, what is the purity of the gas is there? Matlab, at last whatever the gas I am getting, what is the purity of that gas? That will be tested by this purity box, testing box. And then how do you test that? It is by passing a light through this darkening box. Okay, so this is my testing box. Now what is happening, children? Once it is being tested, now it is passing through this tower, that is called my contact tower, after which this entire process is being named. So what happens here, children? Here the oxidation takes place, and then how does the oxidation take place? With the help of a catalyst. Now since the catalyst is being used, that is why we call this process as catalytic oxidation. Now what is happening, children? So for catalytic oxidation of sulfur dioxide to SO3 which is there, then what we'll be doing, we'll be passing sulfur dioxide and oxygen through iron tower, that is being packed with vanadium pentoxide catalyst, initially heated to 450 degrees Celsius. Okay, children, so what is happening here? In this process, I want to oxidize SO2 and I want to convert it into SO3. And then how am I going to do this? There is a tower which is there in reacting the things, the sulfur dioxide and oxygen, and then what will be the catalyst that I'll be using is vanadium pentoxide, that is V2O5. So this is the most important chamber of the process. We are using this particular catalyst which is there to convert the SO2 into SO3. Okay, and what is the temperature? If you see, the temperature which is there is 450 degrees Celsius. So it's quite very high temperature. Now in the fourth one, if you see, we'll be moving to the last part of this process. Here we have absorption tower. So what happens in absorption tower, children? If you see the J1 here, what we are having, the sulfur trioxide that we have obtained in the contact tower, that we are going to absorb. Okay, and then how are we going to absorb? See, the vapor form which is there, by I'll be just passing the stream of concentrated H2SO4. Now here if you see, the SO3 that I have collected here, from that I'll be passing concentrated H2SO4 from the top. Okay, and that the concentration should be equal to 98%. So you can see that how much concentrated it is, only 2 parts of water. So it's highly concentrated. And then what happens in the K, if you see, children, this is the last tower. Here what is happening, for the dilution of oleum by flow of requisite amount of soft water. Okay, so whatever product I am getting here, children, upon the reaction of H2SO4, so that what I'll be doing, that I'll be diluting by using only soft water, children. Okay, when we talk about soft water, it means it should not have any magnesium and calcium salts in it. Okay, and then requisite amount means what, children? That the amount should be there in a requisite or the required quantity. Now to just summarize it, children, I'll tell you once again this what is happening here. Initially we'll be passing air from A, and in the B I'll be heating what? Either sulfur or pyrite. Now in those two mixture will be passed to this tank C, wherein the steam is being flowed. And why are we flowing steam? Because I want to remove the impurities. Now since the temperature of this chamber goes very high, this will be sent to this cooling pipe which is there, children, the D1. Then after D, this is being sent to E, which is called scrubbing tower. As the name suggests, here also we will be trying to remove the impurities. So we will be passing water from the top, and whatever impurities are there, they are being removed. And then since we are passing water, then the mixture becomes moist. So if I want to dry that particular mixture, I will be passing it to the drying tower, wherein I will be pouring in concentrated H2SO4 from the top, which will be absorbing the moisture. And then I will be passing it to the arsenic purifier, and as the name suggests, I will be just removing arsenic oxide which is there in this particular tower. And after all this process, whatever the purity is there will be checked through this testing box by passing the light. Okay, so if you are passing light, children, it is understood. So if you are passing light, children, it is understood that you are just testing the whatever the purity which is there, because if the light is passing thoroughly, means what? The air is pure, and if it is blocking, if the intensity of light is less, then you can just conclude that air is not very pure. So the purity is being checked here at the point H. Now what is happening, children? Then whatever the purified air is there, that is being passed to the contact tower. So this is the tower based on which the name of the process has been named. So this is called contact tower. Now this is the most important tower, children, and here what is happening? The sulfur dioxide which is there, that is being converted to sulfur trioxide. Okay, and then how is this conversion taking place, children? As the name suggests, oxidation process is taking place. So the oxidation process, I'll be just adding oxygen to it, and then whenever I am doing this, and then what is the most important thing here, children? The conditions which are there. Okay, because this conversion does not take place only by the process of oxidation, but it also involves use of vanadium pentoxide as a catalyst. As the name suggests, children, this is a catalytic oxidation, means the process of oxidation is taking place in the presence of catalyst. So here vanadium pentoxide is acting as a catalyst. The temperature that is being provided is somewhere between 450 and 500 degrees Celsius, and then we also provide a pressure of 1 to 2 atmos. Okay, so this much pressure is being applied. So these are the three conditions which are there, children. Then only this sulfur dioxide is being converted to sulfur trioxide. Okay, so this is what is happening in this particular tower, which is called the contact tower. Okay, now once it is being converted to sulfur trioxide, children, this is being passed to the absorption tower. If you can see, this particular tower is called absorption tower. Now absorption tower, what is happening, children? See, whatever the SO3 that has been prepared, okay, the vapors of this are being absorbed by what? The vapors are absorbed by the stream of, if you can see, we are just giving a stream of concentrated sulfuric acid. Okay, so why we are pouring? Because I am just absorbing whatever the vapors are there by just passing the concentrated sulfuric acid. And then what happens in the last process? So what happens, children? What is the thing that is being prepared? So once it is passing through the absorption tank, see, the SO3 which is there, this is being reacted with concentrated H2SO4. So whatever I am getting is called, see, this is H2S2O7, this is pyrosulfuric acid, and this is also called, in short, this is called oleum. Okay, then this oleum is being transferred to the dilution tank. Okay, this is the dilution tank which is there, wherein you will be pouring the ample amount of water, the amount of water that is being required. So when you are adding water to this is getting converted to 2 times of H2SO4. Then what is my condition, children? The water should be soft water. When we talk about soft water, what is soft and hard water, children? Hard waters are the water which contains the compounds of magnesium and calcium. So when we talk about soft water, it should not have these compounds. So these are my conditions. Just to revise about, children, in short, I'll be telling you what all things are there. So you now know already. So here what are we doing first? See, through A I'll be passing air, through B I'll be heating sulfur compound. It can be sulfur or it can be iron pyrite. And then once we are heating, then this is going into this tower that is called dusting tower. In there, what is happening? Whatever the dust particles which are there, they are just being blown away by the steam. And then since you are passing steam, the temperature of this tower is getting increased. So this is being passed to the, if you can see D, which is there, which is called cooling pipe. Once it is passing through cooling pipe, the temperature subsequently subsides, and then we are passing it to the scrubbing tower. As the name suggests, see, the scrubbing tower means you are just again removing the impurities which are there. Okay, now once you are adding water to this, the mixture is tending to become more and more moist. So how are you removing the moistness which is there, moisture? By just acting concentrated sulfuric acid, which tends to absorb the moisture. Then we are just passing it through G, which is called arsenic purifier, wherein you are removing the arsenic oxides. Then it is being passed to H, wherein you are testing the purity of the net gas which is being produced. So now what is happening here in this contact tower, the SO2 will be getting the sulfur dioxide, whatever we are getting from here, this is being converted to sulfur trioxide. Then this sulfur trioxide is again passed to this absorption tower, wherein it gets reacted with the concentrated sulfuric acid to form oleum, which is also called pyrosulfuric acid. And then this is being passed at last to the dilution tank, wherein I will be adding ample amount of water, of course the soft water, so that I am going to get the end product, that is my sulfuric acid. So this is the entire process of contact. This is the entire process of manufacture of sulfuric acid, which is also called contact process. Alright, children, so we'll be just now looking quickly into whatever the reactions which are there, which are involved in this process. So if we talk about reactions, children, see, in all the tanks, see, what are the reactions wherein which are taking place? I'll be telling you, children, this is a place where reaction is taking place, wherein you are converting sulfur or whatever pyrite is there into sulfur dioxide. Okay, further, where is the reaction taking place, children? It is taking place in the contact tower, wherein I am just converting SO2 into SO3. Further, the reaction is taking place here, where SO3 is being converted to oleum, and at last this oleum is being converted to sulfuric acid. So these are the 4 places where the reactions takes place. Now the first, if we talk about where we have sulfur or the pyrite burner, here if the sulfur is being heated, it is directly giving me SO2. And when the pyrite is being heated, children, suppose we talk about FeS2, what is happening whenever we are heating? Of course you need to write down the balanced reactions which are there, children. It is giving me this Fe2O3, the ferric oxide, and of course then I'll be getting the sulfur dioxide. So the ultimate, my aim is to get sulfur dioxide. So this is what is happening in sulfur or the pyrite burner which is there. This process goes on. And then what happens in the next process, children? If you see, the next one is called my chamber conversion. Now what happens here, children? See, in this chamber conversion, this is the thing, contact tower. This is the contact tower. Here, as we know, what is the reaction? This is the most important reaction in the entire process of the contact process, children, the entire process, this particular reaction you need to remember, because here there are certain conditions which are there is certain temperature which is there, certain pressure which is being applied. So it is very important for you to remember this. So here what is happening, SO2 is being reacted with oxygen, which is air, and then if you see, this is a reversible reaction. So what am I getting? I am getting 2 times of SO3 plus ample amount of heat. Whenever we talk about the heat being generated, it means what? It is an exothermic reaction because heat is being released. Okay, and then what is the catalyst which we have studied, children? The catalyst here will be V2O5, that is my vanadium pentoxide. The temperature that I need to provide is equal to 450 to 500 degrees Celsius, and then the pressure is 1 to 2 atmospheres. Okay, so these are the conditions which are there. Now what happens next? Whatever the SO3 that has been produced, children, that is being passed to what? That is being passed to the absorption tower. So these SO3, so this ultimately this becomes only SO3 if we talk about. Okay, so this SO3 which I am getting here, this is being reacted with H2SO4, the concentrated one, and then what is happening? H2S2O7 is what I am getting, which is called pyrosulfuric acid, or it is also called the oleum. Okay, so now this oleum is being passed to the last tower, which is called my dilution tank. So as the name suggests, you are just diluting it, you are adding to it water, and then whatever you are getting is 2 times of H2SO4. So this is my end product. So this is the entire process of the production of the sulfuric acid which is there, children. These are the reactions which are involved. Now we'll be quickly looking into the summary part which is there. Okay, so we have studied this already. In the summary, what you have, the reactants. What are the reactants, children? Means what are the initial raw materials that you need for this process is, the first is my sulfur or the pyrite which is there, and then I'll be needing what? Vanadium pentoxide. These are the products that I need to form the last. These are the reactants which I need to form the last product. Of course, V2O5 is not a reactant, it is a catalyst. Means what? It is not participating in this particular reaction, it is just accelerating the reaction. Okay, and then what is happening? What is the condition, children? We have studied this already, 450 to 500 degrees and the pressure of 1 to 2 atmospheres. Then what is the product that I am getting, children? The product that I am getting is sulfur dioxide in the pyrite burner. In the contact tower I am getting sulfur trioxide. In the absorption tank I am getting pyrosulfuric acid, which is also called oleum, and in the dilution tank I am getting the final product, that is my sulfuric acid. Okay, and then what is the last process which is there, children? This has been done, and these are the equations that are being involved that we have discussed already. Alright, so this is the summary of the contact process. Now moving to the next part, children. This is the next part wherein we'll be just studying various other things that are related to the contact process. Okay, now see what is happening. Sulfur or pyrite burners, so in that what is happening? Okay, so in the sulfur or pyrite burner, sulfur dioxide is obtained by burning the sulfur or iron pyrite. Okay, so this we know already. So S plus O2 is giving me SO2. Okay, now what is happening? Burning of sulfur or the pyrite in oxygen is preferred to purified air, since the heat energy is wasted in heating the unreactive nitrogen compound in the air. So what is happening, children? Here what am I saying, that whenever I am burning this sulfur or the pyrite form in air, okay, so in air means what, children? If you remember, we have just given in air or in oxygen. Okay, so why are we preferring oxygen in place of air, children? The reason is that because heat energy which is there, of course you need to heat them up. So what is happening, if you are just heating it with the normal air, and lot amount of heat energy is wasted in the heating the nitrogen which is there. Okay, children, so you know already that 79% of the air contains nitrogen. So we have different compounds of nitrogen, that is we have NO3, okay, and then we have NO2, other parts. So what happens, a lot of energy is heat energy which is there, that is wasted in the process of heating these unreactive elements, the compounds which are there. So that is why we always prefer oxygen, because if I am just heating it in oxygen, then these waste of heat energy will be less. Okay, now what is happening, the second thing is that purification unit. Now what is happening in the purification unit, if you remember what is the purification unit, from C to H, whatever the paths were there, that particular area was called the purification unit. Now here the gaseous mixture of sulfur dioxide and air are passed through the purification unit before entering the contact tower. You know what is the entire purpose of passing it to the purification unit? It is that I want to purify the sulfur dioxide that I am getting before it enters the contact process. And the final and the ultimate thing is that only, children, we don't want to waste our resources. That is why we are purifying the air. Now what is happening, what are the impurities which are present, children? Okay, for that I'll be talking about the impurities. So which we talk about the impurities. So the impurities are the gaseous mixture of SO2 and O2 that will be containing the following impurities. See, so first will be my dust particles, children. Okay, of course these are the primary things that are found everywhere. So the external dust particles which are there. Then the second thing which we talk about is pyrite dust. Okay, whatever the dust related to the pyrite ore is there, that is called pyrite dust. And then of course we have arsenic oxide, and we already have a chamber for removing arsenic oxide. So these are the primary impurities which are there, and these are the things that we need to remove. Okay, and then what happens next, why do we remove, children? Because the impurities which are there, if they are present, they tend to poison the catalyst and therefore reduce the efficiency. Obviously, children, you all know that why are we applying so many steps for the purification? Because I don't want to reduce the efficiency of the process. Okay, what happens usually in when the entire process is going on in contact tower? Okay, so what happens, the impurities which are there, if they are not removed, then they just tend to deactivate or poison the catalyst. Okay, deactivate the catalyst means what, children? Why is the catalyst being used? Because I want to increase the efficiency. Now if that only is getting deactivated, the entire process will get slow. So that is the reason why we need to remove the impurity. And then what is the method of removal, children? The dust particles are removed. Right? We already know that there was a dusting tower, there was a scrubbing tower, and then we had a arsenic removal tower. Okay, so these three are the chambers wherein we were removing. So in the steam tower, if you remember, in the dusting tower, we were just passing the steam, so that is just remove the external impurities which are there. In the scrubbing tower also we were removing the dust particles which are, and in the arsenic oxide tower which was there, then here we were removing the arsenic oxide which was there. So this was the purification unit. Now in the next thing, children, what was the reactants which were there, children, in the contact tower? See, these are the things that we have discussed already, children. So the reactants which was there is, you know, that SO2 and O2. Okay, and since it is called catalytic oxidation, means I'll be passing the catalyst V2O5. And then the temperature. So what was the catalyst? Vanadium pentoxide is preferred as a catalyst, and then you now must know the reason why vanadium pentoxide is preferred. Okay, so what is happening to there is another catalyst which is there, that is called asbestos, children. Okay, but then why do we prefer vanadium pentoxide? Because the first is that it is cheaper. Okay, and then it is less susceptible to impurities. And of course the second thing is that it is less easily poisoned. When we talk about less easily poisoned, children, it simply means that it is not getting easily affected by the impurities. So this is the reason. So this is a question that you can be asked, that why do we prefer vanadium pentoxide over platinized asbestos in the process of production of sulfuric acid. Okay. Now the second thing is there, what is the promoter which is being used? The promoter that is being used here is, see, with a powder of promoter, usually potassium oxide, to enhance the activity of the catalyst. Okay, so promoter means what, children? That is also added. It is added to enhance the further efficiency of your vanadium pentoxide or the catalyst. So here what is there? It is potassium oxide. Alright, and the third point which is there is the catalyst only initially heated. Okay, the contact mass being porous facilitates the access of the gas to the interior of the granules. Now the catalyst mass is only initially heated electrically, since the catalytic oxidation of sulfur dioxide is an exothermic reaction and the heat produced maintains the temperature. Okay, so what is happening, children? Throughout the process we are not heating the catalyst, we are only initially heating the catalyst till it is attaining a temperature of good 450 to 500 degrees Celsius. Then we just stop heating. Why? Because we have studied, children, that this is already a exothermic reaction, means heat is being evolved, and that much heat is sufficient to form the particular, to maintain the temperature of 450 to 500. So the vanadium pentoxide which is there, that is heated only initially till it is reaching that desired temperature. Okay, now we'll be talking about temperature, children. We have already studied the temperature has to be between 450 and 500 degrees Celsius. And then what is happening? How much is the amount of heat that is being released, children? It is 45 kilocalories. Okay, and that is why the reaction is called exothermic. Okay, now exothermic reaction is favored by lowering the temperature. If you have studied the Le Chatelier's principle, what is happening, children? That if I want to just maintain an exothermic reaction, okay, by how can I do that? I can do that by lowering the temperature. But then if the temperature is becoming very low, then the reaction will slow down, means the efficiency of the production will increase. And then what is happening? Hence the optimum temperature is what? The optimum temperature is 450 to 500 degrees Celsius. And then what is happening at this particular temperature? The sulfur dioxide is getting converted to trioxide and the efficiency is almost 98%. So this is the temperature we are maintaining, children. What is important, children, here? That 450 to 500 degrees Celsius, and how much amount of the heat that is being generated is 45 kilocalories. Now if we talk about pressure, children, how much is the pressure that we are applying? The pressure is equal to 1 to 2 atmosphere. Okay, and then what is happening here? The forward reaction is being favored. If you can see here, this is a reversible reaction wherein I am having forward and backward reaction. So if I want to have the reaction in the forward direction, means if I want more and more production of SO3, I'll have to do that by increasing the pressure. Okay, and then what happens? The forward reaction is favored by increasing the pressure. If the reaction takes place with decrease in volume, as in the case of catalytic oxidation of SO2, which takes place with the decrease in volume. Therefore, what is happening? High pressure favors the yield of sulfur trioxide but may cause damage to the lead pipes and acid resisting towers, children. Okay, so what is happening? That is why, that is the reason, although I know that the forward reaction can be favored by increasing the pressure, but then I won't do that. Why? Because increasing the pressure can be a damage for the pipes and the acid resistant towers which are there. So that is why we are maintaining the temperature to 1 to 2 atmosphere. And then what is there in the absorption tower, children? In the absorption tower, the SO3 vapors are absorbed. Okay, this we have studied already. The SO3 is being absorbed by H2SO4, and then what is resulting? This is resulting in pyrosulfuric acid, which is also called oleum. Now even though sulfur trioxide is an acid anhydride, it is not directly absorbed in water to give sulfuric acid. Okay, now you must have thought, children, that why are we getting this extra process? Because once I am getting SO3, I can easily react with H2O to form H2SO4. But this is not happening. Why? Because this reaction which is there, this is very, very highly exothermic. Okay, and then what is happening, since it is highly exothermic, it will rise towards the formation of dense fog. Means it will go in the, like, it will start evaporating, so it will form a fog like structure. So dense fog or sulfuric acid particles is formed, and then if I am getting very dense sulfuric acid, then what is happening, it is very difficult for me to precipitate that. Okay, so that is why I am first reacting it with sulfuric acid, I am forming oleum, and then only I am adding water. Okay, so hence sulfur trioxide vapors are first dissolved in sulfuric acid, and then I am adding water to it, and then finally I am getting the desired product. Okay, so this is the entire process of production of, or the manufacture of sulfuric acid which is there. Alright, student, now after doing the process of manufacture of sulfuric acid, we will now quickly move to the process or the physical properties which is there, not the process of the sulfuric acid. Okay, so we will be studying about the properties. The first we will be studying about the physical properties, and then ahead we will be looking to the chemical properties if are there. Now in the physical properties, if you see, children, the sulfuric acid you must have observed in your laboratories as well. So the color which is it is having, the first of all the color is complete colorless. Okay, so it's a water like liquid which is there, and then it is completely colorless. And when we talk about odor, it is completely odorless, means what? It does not give any smell. When we talk about taste, it is slightly sour in taste, and you know, children, that acids are expected to be sour. Okay, so what is happening? The taste which is there is slightly bitter. Now nature is what? It is dense, it is oily, hygroscopic. Now what is dense, children? Dense has got to do with the density. So when we talk that it is very dense, it means simply what? That it is happening, it is having density is very high, and then the particles are very close. And then when we talk about oily, means it has got a texture of oil. When we talk about hygroscopic, it means that it is absorbing moisture from the atmosphere, and this is what we have studied in the process, on the contact process. We just studied that in order to absorb moisture, we were using what? We were using concentrated sulfuric acid. So whenever we talk about that thing, particular thing being hygroscopic, okay, this is hygroscopic. So it simply means what, children? That it absorbs moisture. Alright, so this is the thing. So this is my third property. Then we'll be moving to physiological nature. So when we talk about physiological nature, it is given that it is a concentrated acid, it is highly corrosive in nature and chars the skin black. So whenever there is a term which is chars mean what, children? It is having that much capacity that it can burn your skin and it will turn your skin into black. So this is what is happening. So whenever you are listening the cases of acid burn, children, so that is basically your concentrated hydrochloric acid which is there. When we talk about sulfuric acid, it is having capacity of turning your skin into black. Okay, now the density, if we talk about, we have already studied that it is very dense. So whatever the density of water is, you know what it is, 1 gram per cc. So the density of sulfuric acid is more than this. Okay, so whatever is more, so it is saying that it is having a specific gravity of 1.85. So it is more dense than water. Now when we talk about solubility, children, it is soluble in water in all proportions, means irrespective of how much amount of sulfuric acid you are taking, the entire quantity will be soluble in water. So if it is like 10%, if you want to prepare, that is 10 parts of sulfuric acid and 90 parts of water, that is also possible. If you want to prepare 98% of sulfuric acid, means 98 parts of sulfuric acid and 2 parts of water, that is also possible. So this is what they are saying, that it is giving me solubility in all proportions. Then when we talk about constant boiling mixture, So it is forming a constant boiling mixture, boiling at 338 degrees Celsius and containing 98.5 degrees of acid. So this is my constant boiling mixture. Then we'll be talking about the boiling point, children, which is 338 degrees Celsius, means that is the temperature when this particular liquid that starts boiling. Okay, 338 degrees Celsius. Now what else is there, children? Boiling point of liquid HCl is minus 83 degrees Celsius and dilute HNO3 is 86 degrees Celsius. So you can see that HCl has got a very low boiling point, children, minus 83 degrees Celsius. Okay. Now what is the melting point? The melting point is 10.4 degrees Celsius. So at 10.4 degree, what will happen, children? This will crystallize to a colorless compound. Okay, so it just freezes, because as the melting point suggests that is a particular temperature below which the particular liquid, it will tend to crystallize, or it will tend to form, it will tend to freeze. Okay, so it is freezing below 10.4 degrees Celsius. The next thing when we talk about, children, it's its conductivity. So the conductivity, what if it is a pure acid, it is a non-conductor, and if it is dilute, then it is a good conductor. Okay, so this is about the conductivity. Means what? The pure acid means what, children? Which is very concentrated. So this is a non-conductor. So these things you have to remember. And then when we talk about dilute acid, dilute means it is having the concentration of water as well. So concentration of water is more, so that is the reason why conductivity is getting increased. Okay, so this is a good conductor. Alright, so this is the thing which is there. Then we'll further move to what is happening, that how do we dilute it. Now dilution of concentrated acid is done only by addition of acid to water. Okay, children, so whenever we talk about dilution, what do we do? Dilution means what? Acid is being added with water. Now what is happening, children? See, there is always a method of diluting a substance. Suppose there are two cases, children. There is water in this beaker and then I will be taking acid. Okay, so what happens if I am going to dilute? If I am pouring acid into this, what will happen? See, there is a sudden increase in temperature, and what happens, because of that temperature, this water, it tends to just sprout out. You know, there is a sudden reaction from the water, it starts coming out. So that is why acid is being added to water. Now what happens if you are adding water to acid? Now this acid will start spurting out, and if it starts spurting out, what is happening? There are chances that you will get a acid burn. So this is the reason why we always add acid to water and not water to acid. Okay, so this is the thing that has been given, that if you want to dilute, the acid is added to water and not water to acid, even though the heat is evolved in both the cases. So this is the reason. So this question can be asked for 1 marks or 2 marks, children, that what is the process of diluting a particular acid, and then explain your answer. Okay, and then what is happening? See here, if water is being added to acid, there is a sudden increase in temperature, and acid being in bulk tends to spurt out. If acid is added to water, the water is in bulk and the acid being heavier settles down. The heat evolved dissipated in water itself, and hence the spurting of acid is minimized. So what is happening here? Here also the water is getting spurted out, but then it is getting minimized by, because whatever the heat is being generated, that is being cooled down by the water. So we want the spurting out to be less, and that is why we are adding acid to water. Now the second thing which is there, children, is distillation or boiling cannot be used to concentrate sulfuric acid beyond a certain concentration. Means what, children? See, you cannot use the process of distillation which is there. You know what is distillation, children, wherein you are just heating a particular substance and then condensing it. So that is your distillation. And so distillation or boiling, it cannot be used to concentrate sulfuric acid beyond a certain concentration. So why are we telling like this, children? The reason is the aqueous solution of sulfuric acid forms a constant boiling temperature, boiling mixture, boiling at 338 degrees Celsius, containing 98.5% of the acid. Okay, and then the second point is that a constant boiling mixture is the one which boils without change in composition. Hence, on boiling, the above mixture evolves out. The vapors of both the acid and water in the same proportion as in the liquid mixture. So this is the reason why it is happening, children, that distillation or the boiling is being used to concentrate sulfuric acid, but then that is only up to a certain concentration, not beyond that. Alright, so the next thing we'll be moving to is this part, children, that is called my chemical properties. So what we'll be looking into the chemical properties, children. So here we'll be talking about, see, the first thing which is there is, see, chemical properties means what, children? How is it expected to react with the certain metals or non-metals which is there, or the particular compound. So in the first chemical property, we'll be seeing that what happens, sulfuric acid will be taking as an acid when dilute. Okay, so first we'll be taking it as an acid which is in diluted form. So diluted form means what, children? It is in dilute sulfuric acid. Okay, so what is happening, children? See, dilute sulfuric acid, it always acts as a acid when it is diluted. Means if you are adding water to it, it always acts as an acid. And then you know that what are the properties of acid? How do you conclude that it is a particular thing is an acid or not? See, either it will be having H plus ions or it will be having H3O plus ions. This is hydrogen ion, or else I'll be having hydronium ions. So this is the way you can conclude. Now what is happening, children? If you see the reactions which are there, the H2SO4 which is there, it will be upon splitting, upon dissociation, it will be giving me 2H plus SO4 2 minus. Okay, this is what I am getting. And then what happens, this H plus further, okay, plus H2O, this will be giving me hydronium ions. Okay, and of course I'll be getting, so what is happening, children? So they are trying to balance this equation. Why are we trying to balance? So that I can just cancel out the things which is there. So if this is your multiplying by 2, it is already the reaction that has been given. So what is happening? This H2SO4 and then this H plus and H plus, they will be getting cancelled, because since you are multiplying by 2, so this also becomes 2, this also becomes 2. Okay, just a second, children. So this also becomes 2. Then this 2 gets cancelled. So what am I getting? H2SO4 plus 2 times of H2O is giving me 2 times of H3O plus ions, and then SO4 2 minus ions. So since it is liberating hydronium ions, so that is the reason why it is behaving as an acid. Okay, so if at all the question is asked that show that the H2SO4 is an acid, dilute H2SO4 is an acid, so in that case you will be required to write down these two equations. Okay, and then further how will you be testing? You know that there is a litmus test for acid and bases. So what happens, the dilute sulfuric acid, that is turning blue litmus red. So if blue litmus is turning into red, it is understood that it is a acid. Okay, and then if you have that methyl test which is then methyl orange test, it is turning that into pink. So this is also it is also concluded from that the dilute form of sulfuric acid is an acid. Okay, then what is happening, children? The general reactions of the dilute acid which is there, children. So what happens whenever an active metal, so when we talk about metal, children, so metal can be anything, like suppose we are talking about Na. Okay, so if Na I am reacting with acid means what, children? The H2SO4. Okay, so what I will be writing, suppose the example, if I want to give 2 times of Na, if it is reacted with H2SO4, so what does this form? This will be forming Na2SO4, and then this will be forming H2. The hydrogen is there, that will be liberated. Okay, so when it is being reacted with a base, now children, what is the example of a base? See, base, and that too in the oxide or hydroxide form. So if I want to talk about oxide, children, I will be taking magnesium oxide plus H2SO4. If I am adding, what am I getting? I will be getting what? MgSO4. Okay, that is my salt again, and then I will be getting what? There is a oxygen left over here. I will be getting water. So these are the reactions which are taking place, children. Then whenever the sulfuric acid which is there, that is in diluted form. Alright, so further we will be moving to what, children? We will be moving, if we talk about base, hydroxide. So what can I take, children? I can take as CaOH twice. So when this is being reacted to H2SO4, what is happening, children? What am I getting? I am getting first of all CaSO4 plus 2 times of water. Okay, so here also what is being formed, children? This is salt and this is water. So this is what am I getting. Now what happens when it reacts with carbonate or bicarbonate? Okay, so if we want to take an example of carbonate, I can take what? CaCO3. Calcium carbonate. When this reacts with H2SO4, what it is giving me? It is giving me CaSO4, that is my sulfate, that is again a salt. Then it is also liberating carbon dioxide and it is also liberating water. So whenever a carbonate is reacting with dilute sulfuric acid, it is giving me salt plus carbon dioxide plus water. Okay, similarly if it is reacting with a bicarbonate, so what can be example of bicarbonate, children? It is like NaHCO3. When this is reacted with H2SO4, okay, what will I get, children? I will be getting Na2SO4, that is my salt again. Okay, plus I will be getting 2 times of H2O plus I will be getting 2 times of CO2. So whenever it is reacting with what, children? Whether it is reacting with a carbonate form or it is reacted with bicarbonate form, it is giving me CO2 and water along with the salt. Here also salt plus H2O and CO2. So this is what is happening. Now what, children, we will be talking about what happens when it reacts with sulfide or bisulfide. So what is sulfide, children? The example of sulfide will be what? See, if I talk about sodium sulfite, if I talk about, that is Na2SO3. Sulfite ion is what, children? This is my sulfite ion. Okay, SO3 2-. So when this is being reacted with H2SO4, what am I getting, children? See, I am getting salt again, that is my Na2SO4, and then further I am getting what? I am getting H2O, and then sulfur dioxide gas which is there from here, it is getting liberated. Okay, so I am getting sulfur dioxide. Similarly, if I talk about bisulfite, not sulfate, bisulfite. So this is, suppose I want to take potassium bisulfite. So this is KHSO3. When this is reacting with H2SO4, so this is also again giving me what? First of all, it is giving me K2SO4, the salt that is being formed, plus 2 times of H2O plus 2 times of SO2. Okay, so what do you see, that whether it is sulfide or whether it is bisulfide, the product is same, only the concentration is decreasing or increasing. Okay, so and the last we'll be talking about sulfide. So what is sulfide, children? Sulfide is whenever we are adding sulfur ion into it. So what that will be equal to, children? I'll be writing like this. See, suppose I am taking again sodium sulfide. So this is Na2S because S is 2-. This is my sulfide ion. Now when this is being reacted with H2SO4, this is giving me what, children? This is giving me, see, I'll be getting what? FeSO4, not Fe, sorry, Na2SO4 plus H2S, means what? Hydrogen sulfide gas is being released. Okay, so these are the reactions of the sulfuric acid which you need to understand. If you just know the certain reactions which are there, children, it is not even important for you to by heart this. You can yourself come to the conclusion. Okay, so if you just look at the table that is being given, so these are the examples of what is happening when it is reacting with active metal. So here I am getting salt plus hydrogen. When it is reacting with a base, if it is an oxide, it is giving me salt and water. If it is a hydroxide, this is also giving me salt and water. When it is reacting with carbonate, what it is giving me, children? It is giving me salt plus water plus carbon dioxide, as we have discussed now. And then when it is reacting with bicarbonate, it is giving me salt plus water plus carbon dioxide again. Now what happens when it reacts with sulfide? When it is reacting with sulfide, it is giving me Na2SO4 plus H2O plus SO2, and when it is reacting with bisulfite, it is giving me salt plus water plus sulfur dioxide. Then when it is reacting with sulfide, what is happening, children? Of course, salt is being produced, and I am also getting what? Hydrogen sulfide gas. So in all these cases, what do you see, children? That in all cases the salt is being produced, but the side products are different. So these are the chemical properties.